Good morning, and today we are going to do Algebra 2 D2, where we're going to be able to identify functions. There are a couple of ways to be able to identify whether a graph or a set of points is a function, and one of them is the vertical line test. And the vertical line test, well, let me back up. Okay, a function. A function is when you do not have repeating x's. And remember, x's go left to right. Okay? So, to be able to know where there's a function, if you're looking at a graph, then you're not going to have two x's. You're not going to have one x with two different y's. Okay? So, on this is the relation of function. Vertical. Vertical is straight up and down, right? So if we do a vertical line test, we start at the left and we scroll this about the line, and our x's do not ever repeat. This would be 1, 2, 3, 4. This would be at 0, 5. This right here would be at 3, 4. This would be at 6, 3, and this one would be at 9, 2. Okay, so our x's do not repeat, and when our x's do not repeat, it is a function. So is this relation a function? Yes, it is. Okay, but let's go to the circle. If we do the vertical line test, boop, there's lots of places where it is not a function. Right here and right here. This would be at 3 and like 1 point, we'll just say 5. And this right here is at 3 and 6, 7, 8, 8.5. Okay, that's just approximating those 1.5 and 8.5. But the 1.5 and 8.5 do not matter. What matters is this x has a y of 1.5 and the same x has a y of 8.5, which means the x's repeat. And if the x's repeat, then it's not a function. So anytime you have a graph and you see any vertical line that passes through the graph twice, then it is not a function. Okay? This dotted line is called an asymptote. It's kind of a weird word. Not really necessarily need to know it for this lesson. In later lessons, we will get into it more in depth. So just in case, just to keep it in the back of your mind though, asymptote. An asymptote is just an imaginary line that the graph doesn't cross. So this line in this case really doesn't matter. If we are looking at this part of the graph, if I do vertical, it never crosses back on itself. And this part of the graph, it never kind of crosses back on itself either. So yes, this is a function. These are the ones I like. Whenever you really don't even have to look at anything except the x's. The y's do not matter. Even though there's 2 8s, it doesn't matter because those are the y's. All we are looking for are the x's. We have negative 10, positive 11, positive 9, and positive 6. None of those repeated. If they do not repeat, then it is a function. Okay? Doesn't matter about the y's. All we're doing is looking at the x's. Uh-oh, we have a 14, and we have a 14. 14 goes to 3, and a 14 goes to negative 15. Same x goes to 2 different y's, so the x's repeat, so it is not a function. And now we are, let me get it a little bit, there we go. Okay, so on this one, it says, which of these relations is a function? See how this kind of loops back in right there? This is not a function, okay? Circles, we've already determined a circle is never a function. This vertical line right there goes through it twice. That is not a function. Okay, we're like, all of these straight lines, both of these are functions. It is not. The reason why this one is not a function, this point is colored in and this point is colored in. That means that this is at 0, -2, and this is at 0, +2. Two x's, sorry, same x goes to two different y's, so it is not a function. Or you're like, well, okay, this one's vertical to each other. Well, they're open. If they're open, they do not equal. They get closer and closer and closer to that point, but it never really gets there. So they do not have the same x. So this one would have been your function. Which of these relations is a function? Okay, it comes back on itself. That is not a function. Okay, see this right here? This is a point, even though it's not a dot. There's still a point there because the line goes through it. And so if that dot and that dot are vertical to each other, then it is not a function. Okay, so I was like, okay, these both, they look pretty good. Well, this one, again, kind of goes, this dot and that dot are on top of each other. This vertical line, that vertical line, that vertical line. They fail the vertical line test, so it is not a function. This dot is open, which means it gets closer and closer and closer to it, but never gets there. And closed point, which means it does, that's okay. As long as you don't have two closed, we're okay. And one open, one closed, we are okay. So that one is a function. And here, now be careful with these. It says select all that apply. Which of these relations are functions? So let's see if I can, okay, this one's not a function because it wraps back onto each other. And these are just when we have to be very, very careful. That's smooth, I like that. That is a function. And closed and open, that's okay. And open and close, that's okay. And they don't cross each other. They don't go under on top of each other. So that is a function. This part would be a function, that part would be a function, and these are both open, which is okay. So that's a function. So when it says select all that apply, it could be one or it could be all. It could be any in between. So those are what's function. Closure. When do you have a function? When the graph passes the vertical line test, if you have a graph, or if you just have points when the x's do not repeat. Thank you. Have a good day.